Hi everyone. This is going to be a quick overview on some of the basic commands that you can find useful in Linux or Unix shell. The intention behind this video is to not allow using the command line interface to be a barrier when using computational biology programs. And so this video is really intended for people who have minimal experience with these types of interfaces. And this is not very hard. It just takes some time getting used to. Right, let's get started. For Windows, you would need to download what is called a Windows subsystem for Linux. And it comes with the Ubuntu distribution. You can find this at the Windows Store. It's going to have a logo that looks something like this. If you have a Mac, you're perfectly fine with using Terminal. Okay, let's log in to a remote computer. You don't have to do this for this demonstration, but I'm just doing this because I have some documents in here that might be useful to look at. SSH allows you to connect to a remote machine. That's my username, and that is the address of the machine. You would use SSH if you were going to log on to a compute cluster, for example. Okay, I've logged in. I use ls to see what documents are in the current folder. When you log into root, which is denoted by a tilde. And here is just a normal computer. You have a desktop, documents, music, pictures, programs, etc. Okay, let's go to documents. We're going to create a folder. Let's call that playground, where we can do some demonstrations. So to navigate around folders, you can change directory with cd and create new directories with make dir or mkdir. Alright, let's go into playground. I actually just need to type in the first few letters of that directory and then press tab to autocomplete. So very useful for long file names. In here I don't have anything yet. Let's create something with a text editor, Nano. There are many other text editors like Vim, but I find Nano to be the most user-friendly. So let's say this is test.txt. On Windows or on any other system with a GUI, text files end with .txt, and that is true. And here, essentially, your file endings are arbitrary. Your file endings can actually end in any letter that's valid. So here I've ended it with .777 just to demonstrate. This is a test. You're editing this blank file, and the only thing that might take time getting used to is to operate on this text editor. You need to use your keyboard instead of your mouse. So here are some of the more common commands down here. To exit is Control X. So the joke is on Vim there is no instructions. So the first time you use it, you don't know how to exit Vim. You're just trapped there and stuck there forever. But here we have Control X, click Y to save that file, and we see we have test.777. Great. More useful commands with Nano I'll show you with larger files, but here that's not really necessary. Let's just remove it. We can remove a file with RM. Again, auto-completing it. There we go. Great. Let's create another file because we can. So this is a really weird extension, right? But it's valid. Alright, so that's your file name. Let's save that again. Now we have this file. We can rename this file with mv, moving the file in this name to another name. That's how you can think about it. So you're moving do to don't do .test. Here you go. You can also create subfolders within this playground folder, and just for fun, let's create 100 of them. So let's create directory 0, and I can press the up arrow to get the previous command, or you can go all the way back to the beginning and press the down arrow to navigate through your history of commands. So you can do make directory 1, Wow, okay, so this is like almost a computer game where you try to press as many keys as you can. that's not really how to do this efficiently. So the really powerful tool that you can leverage in Unix shell is the ability to script operations on your file system. So you can actually make 100 directories with one line of a command. So what you can do is to start for loop. Here I'm going to say my index is I. For I in, let's say, the range, well, I've already created 0 to 4, so let's start with 5, and let's go up to 100. We can do 1,000. Okay. This iteration will go from I equals 5 to I equals 1,000. So this is inclusive on both ends. I'm going to create the directory, so mkdir. I'm going to make directory with prefix dir, and that's going to end with the variable I, the value inside variable I. I can get that value by enclosing I with this syntax. So dollar followed by these curly braces. And then another semicolon, done. Now this is the usual syntax for for loops. If you want more commands, essentially the for loop starts here, ends here. If you want more commands in the middle, you can say echo making directory, and then you end with a semicolon. Okay, actually it would be useful to say making directory and then the $I of what you're actually making. Echo essentially is the print operation where you're printing onto the screen. This is really unnecessary, I know, but it really demonstrates the power of Unix shell. This might actually be necessary for some of your programs that you might be running. Suppose you want to run 1,000 experiments in parallel, you can just do this with one line. Hopefully this works. There we go. And it shows you what it's making, so it's super fast, and indeed we've got 1,000 directories. Alright, so this just fills up our screen. Let's just remove all of these, right? But before we do that, we're going to copy a file into every single directory. Okay. Maybe we want to copy it to every single directory, so let's do a for loop again for file or for directory D in whatever starts with dir. Well, we can do it like this. So dir star means everything that all of the files or directories in your current folder that start with the letters dir underscore and whatever follows it. So asterisk is a wildcard. And you want to copy the don't do into all these directories. Sorry. This needs to be a $D because you want the value that is in D. Sometimes you don't need to enclose it in the curly braces, but I think it's good practice to enclose it just for readability. Semicolon again, and then done. Hopefully this will work. It will take a while. This is 1,000 directories. Let's just change into an arbitrary one like this one. I should talk about copy and paste. So what I'm doing is double clicking, pressing Control C or Command C on Mac to copy, and then to paste you press the right mouse button, or you can press the scroll wheel. That might work on Unix or Linux computers. So I can change into this directory, and there we see we have don't do. All right, now, well, you can maybe think where I'm going with this. This doesn't have to be copied into all directories. You can make a file that says do only for the 100s dot don't do. All right. This makes no sense. I'll save this file, and we're going to copy this into all of the directories that end with suffix 1 that are in the 100s. And we can do that very easily by going up to this command, changing this thing into do only blah blah blah, You can autocomplete that with tab. And then for all those directories that start with dir_1, because you just want to copy it into the 100s, suppose that's a subset of an experiment that you want to do. Okay. Another useful thing to navigate around lines is home and end. So you can see my cursor jumping around. I'm pressing home to jump to the beginning and end to jump to the end, instead of doing like this with the arrow keys, which can be very annoying if your line's long. Okay. So now in all of these folders that have dir_1, whatever, you have these two files. Okay, great. Now I promised we're going to delete everything. I want to delete all of these 100 directories, so again we can play a game and say remove -rf. rf is required here because your directories are not empty. And well, let's just try to see what happens if you just remove something. So you can remove a regular file like don't do.txt, but you can't remove a directory just with rm. So you can't remove, for example, directory 8. It's going to say it's a directory, but there's also this command remove directory. So that might work, but doesn't because directory is not empty. And why this is the case is because you need to specify this recursive delete, where you're deleting all the files that is nested within that directory, including the directory itself. So I can do remove -rf by specifying these options for remove, dir8, and that's going to do it. If I want to remove all of these directories, I simply do rm-rf, anything that begins with a dir. And there you go. All of these are gone. Powerful, right? But with this power, you need to be really responsible into thinking that when you're using RM, gotta be very careful, as you can't recover it. Unlike Windows, where there's a recycling bin, there's basically no way where you can recycle or recover these files. So how do you know to use RF? Well, Stack Overflow, right? But you can also use this help utility like so, and it can show you the meaning behind all of these flags. And the flag is essentially these options that you provide to your program. And the program I'm using is the remove program, which is included with Unix. So r-r means recursive, and -f has its own meaning. And then if it's helpful, it might give you some examples as well. Great. I have a lot of text on the screen. I don't want to see all of this anymore, so we can clear it with clear. Excellent. Now let's get into more meaty business with dealing with PDB files. I'm going to download a PDB. I have one right here, 6EQD. This is PETase, plastic degrading protein. PDB files store the structure of proteins. That's very helpful if you want to do some sort of MD simulation on it. So let's download the PDB. Clicking on this will download it on my own computer, which then I have to sort of copy it onto the remote cluster. I don't want to do that. I can save time by just knowing the download address. All right, copy link address. And I can do wget so this command downloads a file from the internet. It's going to do that. Let's remove this confusing file. And now we only have 6eqd.pdb. Okay, let's look into it. PDB files, right? The extension is .pdb, but we can use it, we can just look at it as a text file. And it is a text file, really, with these lines of text that has different meanings. So we have remarks. It's very long. If you want to scroll all the way down with your down arrow, Remember, this was like 7,300 lines. So you can go to a specific line number with Control-Shift_. Suppose you know on line 2000 there's something weird, you can go there. And it's going to jump right to it. If you know something, you want to see something at the end of this file, you go to, again, line number. Well, you can press Control-V to get to the bottom of the file. And that's the end of the file. Suppose you want to delete all these water molecules because they're annoying. Or, well, they're not annoying, but suppose you want to do this for your analysis purposes. You can delete these lines with Control-K, line by line, right? Keep pressing Ks. Or you can do block selection with Alt-A, okay, set a mark. You can scroll to the bottom or the top to select the block and do Control-K to delete that block. You can also indent certain blocks with Alt curly braces, I believe, but try it out. Not sure if that will work or ruin your computer. Just try things out. That's the conclusion. But, you know, if you want to delete, let's suppose I go to the top of the file again. I want to find all the residues with serines. The way to do this would be to use the search utility, Control-W. So I can search, well, first I need to search where the PDB file begins. So atom, that's not really where it begins. You keep pressing it until it works. Keep doing it until it works. Ah, yes, that's the common strategy in coding. You have the first line of your PDB. This is really where the juicy stuff starts because this is the coordinates for all of your atoms. You have your atom, the atom number, what atom it is, what residue the atom belongs to, the chain ID, the residue index, and the 3 atomic coordinates XYZ in Cartesian space. Some more information down there if that's relevant to you. But here you see all the abbreviations for your amino acids, or 20 amino acids. You can find with Control-W, for example, serine. And here we see this is the first occurrence of serine. It's going to go down line by line. Yeah, and it's going to find the next serine. Suppose for some reason you want to just truncate this PDB. You want to just cut it off at residue number 42, remove everything afterwards. So what's really cool is, well, you can do that with Alt-A, set a mark here, then Control-Shift_, Control-V to go all the way to the end, and then Control-K to delete everything. This is not going to be a working protein anymore, but you can do like easy mutagenesis operations, i.e. like truncating sections of the protein just by operating on this text file. And you can Control-X. I don't want to save any of my stupid modifications, so I say no. Okay. Whoops. We still have 6EQD here. Let's actually do some processing of this file with all of these commands here. I saved these commands, so these are actually available on mdtutorials.org, I believe. Justin Lemoncall has a great website that teaches you how to do MD, essentially. But the purpose of me doing this today is to show you how to, what is the syntax for running programs. Okay. Well, the first line here is this. I'm going to change this argument because we're working with 6EQD. So I actually recommend, if you're doing something, running a program, I recommend you writing the commands down on some text file so you have a reference, and if you're going to run them again, you can just paste that into your command line instead of writing the whole line again. And then changing the parts where necessary. what this does is it removes all the lines that contain water, denoted by HOH. I can see that it works by looking at the result, and that has less lines than the previous one. So go back to the end, and we see all the waters were indeed removed. You might also want to remove the chlorines as well, depending on what you want to analyze. Okay, so let's save that file. We have 2 files now. So the only command I think I will run is the gmx pdb to gmx command. I'm using the software GROMACS, which is for molecular dynamics simulations. Let's walk over this one, and essentially all the other commands pretty much follow the same syntax. It's very generalizable. So the first thing is your program. It essentially tells the computer, I want to run the program called gmx. This is the, well, for GROMACS, this is the syntax, how you would do it. The second one tells you which program of the gmx package you want to use. And all of these things are flags, and they're prepended with a dash. So these flags are essentially inputs or options to your program. Here, I want to input the file complexclean.pdb, and I want to output the file complexmd.pdb. Dash P, I don't know, maybe I forgot what it means. So I can actually just put a dash H at the end to get all the help messages I need. And here somewhere you'll find it, dash P, it's a topology file. So the first time you're using the program, you won't know what these options would mean, so with this help page, you will be able to find out. Here it also specifies that it needs to end with extension.top. So that's clearly what I have here. And some more other options down here. So each option prepended with either 1 or 2 dashes, and that will really depend on how they want you to use the program, which you'll see when you type in dash H. Okay, let's not have the dash H. Let's actually run this program. A lot of programs will allow you to interact with it, which may be a good thing the first time you use it, but it won't be a good thing if you want to automate it. Suppose you want to do MD simulations for 10 different systems. You don't want to type in all of these things every time for 10 times. But the first time, let's just do it. You can select one of these force fields. I'm going to choose 11. And it's going to write the topology and create the necessary files. How do I know what files it actually created? Well, instead of just ls, which is going to list everything without any information, I can do ls-lthr, which will show you very useful information about the files. So the most useful one is, I think, the time last edited. Here we see, well, basically all of these files were changed or modified or added by this command I just ran. This is especially useful when your folder contains a lot of files and you want to know what's the most recent file that you're working with. Another useful representation here, information, is the file size. Why that's useful? Well, let's suppose I want to analyze all of these files. In reality, I'm not done yet with preparing for MD, but suppose I am. We're going to download all these files. You can do it one at a time, but you can also compress it to reduce the file size. In compression for Linux systems, often you use tar. You can also use zip files like in Windows, but often you use C and you use tar. It's very easy to use. You just press these options. Let's see, CVZF. C is compression, V is verbose, Z is a gunzip, and files. You can find out these what these mean by, again, looking at the help page for tar. But let's just do it. The target file, or the target name, let's call it MD. The extension it needs to be in a .tar, but because I specified the Z here, it actually needs to end in GZ. You actually might see this extension a lot if you are downloading software from online. It's essentially a compressed version of a bunch of files. Okay, what files do I want to compress? Let's just do everything in the current directory. So the dot means current directory, asterisk means I want to group everything together in this current directory. Anything in this current directory, and ls-lthr, that's going to show you the compressed file. You can see the file size. It's actually much less than these other files combined, which is great if you want to download things. Something I think I didn't show you is this whole deal with dot and dot. I'm in the folder playground. Suppose I want to go back to the root directory. Well, I can do that with just going cd tilde. That's going to go back to the root. But I can also do that with cd ... which will go back to documents. And then ... again. That's going to go up another level, going back to tilde. And now we're at tilde again. cd-, that's actually very useful because that gets you back to the previous directory you were in. You don't have to go through this whole maze and chain of directories, which can be frustrating sometimes. Well, anyway, we're here. We created this tar file. I want to download it. How do I do that? And where will it download to? Let's log out of my cluster or of my computer, remote computer. Now I am in my local computer. On Windows, it's helpful to know where that is. So it's actually here in app data, local packages, canonical group limited, yada, yada, yada. It's all the way down here. I already have this file because I recorded this previously, but let's delete that. So just to know that this is not a trick, I don't have anything in this folder yet. I'm going to download something from my remote computer to my local one. Do that with SCP. Username, IP address, colon, that specifies, now you can specify the location of your file, which is in playground, and your file name, md.tar.gz. So again, with the dot business, you want to copy something from the source, and the destination will be your current folder. And you specify that with a dot. Let's say if you don't do a dot, it's not going to work. So you need a dot there. Prompt me for my password. Enter my password, and it's going to download the file. And it's right here. Shows up. Recently modified. With tar.gz files, you can extract that with 7-zip. Great. I think that's pretty much it covers pretty much most of the basics of this Unix shell. For other problems or other issues, commands that you want to use, hopefully this would let you ask the right questions on Google, and then you can find the answer on Stack Overflow. That's, I think, a great strategy if you want to get a quick answer. Of course, I mean, you always have the option of looking through the help pages of your programs that you're running. But essentially the key is to ask the right question. So all of those commands, pretty much, you can find answers on Stack Overflow. One thing I didn't show you that I think is useful, just found in my notes, is this command. This is a bonus command. Very useful command. That shows you how many files are in your current directory. This is especially useful if you're dealing with a lot of data, because if you do ls, that's just going to fill up your screen. This lets you know how many files are in your current directory. Many other commands are necessary, but don't have the time to go through all of them here. I think the basic commands were pretty much covered. So thanks for watching this far, and hopefully you have fun playing with command line programs. Thanks.